Today I'm going to look at integrating this integral of 3x times x squared minus 5 raised to the third dx. So the method that we want to look to use here is u substitution. And there's a really brute force type of way of doing this where you could actually just multiply out this x squared minus 5 to the third by x squared minus 5 times x squared. You could do that, not impossible. But if you could use u substitution, I would try to steer that way just to save yourself some headache and some time. So u substitution, we want to look for a term where when I take it, when I set it equal to u, and I take the derivative of that term, I get something that I could substitute out. So let's take a look. We have this binomial being raised to this exponent. That's typically where we want to start with our u substitution. We want to set that u equal to the inside of that. And what hopefully happens then when we take the derivative, so if I take the derivative of u, so that's going to be du equals 2x dx, 5 is a constant, so that's just 0, so the derivative of x squared is 2x, because 2 times 1 is 2, minus 1 is 1, so 2x to the first. And look what happens though. Look how that helped us, because I have x dx, x dx. Now I know we have some constants floating around, but you could rewrite this as 3 times x squared minus 5 raised to the third dx, and then you'll see that direct substitution there. Everything cleans up really, really nicely, because if I just solve for the x dx, you get du over 2 equals x dx, and there's our substitution, x dx. I have the x squared minus 5. I set that equal to u. So I'm going to replace everything. I'm going to put back in x dx, and that's a 1/2. So I'm just going to take that out. So I'm going to rewrite this as 3 over 2 integral of u to the third du, because I replaced x and dx with du. And then I still had that constant of 1/2. This is technically like a 1/2 times du. So I just took that constant out of the integral, just like how I did for this 3. You can take that out. Those constants don't need to be in the integral. So now we just have to integrate u to the third. So integrating u to the third is going to be u to the 3 plus 1 over 3 plus 1. So 3 plus 1 is 4 over 3 plus 1 is 4. And that is being multiplied by the 3/2. And I know I have the plus c coming, but let me just clean this up first. So I have 3 u to the 4th over 8, because 2 times 4 is 8. And then we have the u to the 4th. So let's substitute back in u to the 4th. I'm getting kind of low on my page here. Let me just go this way. So now I put back in u. The u that I replaced was x squared minus 5. So I'm putting back in u. So x squared minus 5 over 8 plus c. And there is our integral. So what looks like a complicated integral using u substitution is really not so bad. And again, you could do the long route of multiplying all this out, but you want to be familiar with the u substitution method, because what if that was like to the 5th or 6th or 10th or 20th or 45th? Like, you don't want to rely on just brute force. That's a lot of work. So using u substitution though made this much more manageable and not too complicated. Not easy, but not too complicated, where I think we were able to get through it. So hopefully this helped you out.